This is SpaceTime Series 29, Episode 31, for broadcast on the 13th of May 2026. Coming up on SpaceTime, planet Earth's balance is shifting, a unique insight into the Sun's inner life, and Landsat 9, more than just a picture. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims planet Earth's balance is shifting. The findings, reported in the Journal of the Proceedings of the National Academy of Sciences, PNAS, showed that the Northern Hemisphere is now absorbing significantly more solar energy than the Southern Hemisphere, a shift that could reshape global weather patterns. Since 2001, the Northern Hemisphere has been retaining approximately 0.34 watts more solar energy per square metre every decade compared to the South. This growing energy gap is driven by a combination of environmental changes that have fundamentally altered how our planet reflects sunlight. As snow and ice melt, they expose darker land and ocean surfaces, which soak up heat rather than reflecting it back into space. At the same time, a decline in air pollution across the north has cleared the atmosphere of reflective aerosols, while rising water vapour levels further trap heat, creating a feedback loop of warming. Perhaps the most startling discovery is that the Earth's natural cooling mechanisms are failing to keep pace. Scientists previously expected cloud cover to increase and offset the extra heat absorption, but recent data shows clouds aren't stepping in to restore the balance. This discrepancy challenges existing climate models and suggests that the planet's ability to self-regulate its energy may be far more fragile than previously thought. The thing is, as this hemispheric divide widens, the resulting pressure could trigger significant shifts in rainfall patterns and storm tracks across the world. This is SpaceTime. Still to come, a unique insight into the Sun's inner life, and Landsat 9 proving to be more than just a pretty picture. All that and more still to come on SpaceTime. Astronomers have analysed more than 40 years of stellar data to uncover new evidence that the Sun's internal structure subtly changes from one solar cycle minimum to the next. The findings, reported in the Journal of the Monthly Notices of the Royal Astronomical Society, are showing that even small differences in solar magnetic activity produce detectable changes inside the Sun. Every 11 years, our Sun goes through a cycle of intensifying magnetic storms, with lots of sunspot activity triggering violent solar flares and coronal mass ejections, which blast billions of tons of plasma, charged particles of magnetic field into space, and occasionally towards the Earth. This period, known as solar maximum, wreaked havoc over the past year, pummeling the Earth with powerful geomagnetic storms affecting satellites, navigation systems, communications networks, and terrestrial power grids. But over the past week, there have been virtually no sunspots seen on the Earth-facing side of the Sun. Of course, that's likely to change as the Sun's far side rotates round. Nevertheless, the Sun can be expected to start to quieten down again as it slowly proceeds to solar minimum, its calmest period when few if any sunspots are visible and solar magnetic fields are all relatively weak. Solar minimum is when the Sun's magnetic poles flip polarity. The North Pole becomes south and the South Pole becomes north. The last polarity flip was back in November 2019, marking the start of the current solar cycle 25. The next is expected sometime around 2030. Using observations from 6 telescopes sited around the Earth known as the Birmingham Solar Oscillations Network, or BISON, astrophysicists looked at what happens inside the Sun during 4 of its quietest periods between solar cycles 21 and 25. Researchers analysed tiny vibrations in the Sun formed by trapped pressure waves which make the Sun gently oscillate. This allowed them to infer what's happening deep below the Sun's surface, a process known as helioseismology. This was the first study to compare 4 successive solar minima by looking inside the Sun using these oscillations. Astronomers look for a distinctive sound wave or glitch created when helium becomes doubly ionized, changes in sound speed, as well as comparing observations against predictions from solar models with slightly altered internal conditions. They found that the solar minimum, which occurred in 2008-2009 between cycles 23 and 24, which was known to be one of the quietest and longest on record, showed measurably different internal conditions compared to the other three minima. The helium glitch was significantly larger than in the other three minima, indicating a real structural difference. The Sun exhibited a higher sound speed in its outer layers, suggesting higher gas pressures and temperatures and lower magnetic fields. One of the study's authors, Bill Chaplin from the University of Birmingham, says it's the first time researchers were able to clearly identify how the Sun's internal structure shifts from one cycle to the next. The Sun's outer layers subtly change across activity cycles, and Chaplin and colleagues found that deep quiet minima can leave a measurable internal fingerprint. The new findings could prove useful for forecasting future activity cycles. Revealing how the Sun behaves beneath its surface during these quiet periods is significant because this behaviour has a strong bearing on how activity levels build up in the following cycles. Chaplin says the work demonstrates the power of long-term stellar seismic observations. With upcoming missions such as the European Space Agency's Plato, the techniques used in this study could be applied to other Sun-like stars, helping astronomers better understand how their activity changes and how they influence their local environments, including any planets that might orbit around them. This is SpaceTime. Still to come, Landsat proves it's more than just a pretty picture, and later in the science report, a new study shows that teens who use cannabis are far more likely to develop psychiatric disorders. All that and more still to come on SpaceTime. This episode of SpaceTime is brought to you by Squarespace. If you've ever wanted to make your mark online, whether you're just getting started or ready to take your business to new heights, Squarespace is the all-in-one website platform specifically designed to help you stand out and succeed. With Squarespace, you can easily claim your domain, build a beautiful website, showcase your skills and products, and even get paid all in one seamless place. Let's talk about why Squarespace is recommended for anyone looking to offer professional services online. First, offering your services couldn't be easier. Squarespace gives you everything you need to impress your clients and streamline your business. You can set up a custom website to showcase consultations, events, or any experience you provide. And here's where it gets really exciting. Squarespace's design tools give everyone the power to create a website that looks like it came from a top-tier design studio. The result is a website that is unmistakably yours, no coding or design degree required. And to make sure people actually find your beautiful site, Squarespace includes SEO tools that work in the background. Now, if you want to see how easy it is to bring your ideas to life online, visit squarespace.com/spacetime for a free trial. And when you're ready to launch, use the code SPACETIME at the checkout to save 10% on your first purchase for a website or domain. That's squarespace.com/spacetime, promo code SPACETIME, and of course we have a link in our show notes. For more than 50 years now, the Landsat program has provided the longest continuous satellite record of Earth's land surface from space. Landsat 9, launched back in 2021, is the latest mission in this remarkable legacy. It builds on decades of Earth observation and uses upgraded technology, including enhanced radiometric resolution, improved signal-to-noise performance, and polar night thermal imaging. Working in tandem with Landsat 8 to map the entire planet every 8 days, Landsat 9's data is being fused with the European Space Agency's Sentinel-2 satellites, enabling near-daily global observations, in the process delivering sharper, more detailed observations which are helping scientists and communities monitor a changing planet. This report from NASA TV.
It started over 50 years ago with an idea. A satellite, orbiting Earth, observing our planet's surface, gathering data, day in, day out. That idea gave birth to the Landsat program, a partnership between NASA and the U.S. Geological Survey, the longest continuous record of Earth's land surface from space. Landsat 1's launch in 1972 was the first link in a chain of 8 satellites, each one building upon the last. And today, Landsat 9 carries that legacy forward.
2, 1, engine ignition, and liftoff.
Since its launch in 2021, Landsat 9 collects as many scenes per day as Landsats 5 and 7 combined. Working in tandem with Landsat 8, the pair now collect nearly 1,500 scenes daily, creating a complete map of the planet's land surface every 8 days. It's not just about scale. It's about Landsat's ability to revisit the same scene multiple times a month. With the pace of acquisitions, Landsat 9 helps track seasonal shifts in crops, the spread of wildfires, the aftermath of storms, and even rapid changes in glaciers and coastlines. More images means more data, fueling research and scientific applications around the world. While Landsat 9's main design is nearly identical to Landsat 8's, it's able to collect data in greater detail thanks to an upgraded radiometric resolution, 14-bit instead of Landsat 8's 12-bit. Think of it like upgrading from a box of 4,000 crayons to one with 16,000. Every shade captured, every subtle detail sharper. Landsat 9's quadrupled radiometric sensitivity makes a real difference when capturing data over the planet's brightest surfaces, like snow and ice, revealing subtle changes that might otherwise go unnoticed. Shifts in ice extent, changes in how surfaces reflect sunlight, and even the growth of glacial lakes, forming where ice once stood. Seeing more shades of detail is powerful, but it only matters if the picture itself is clear. Landsat 9 not only sharpens what we can detect, it also cuts through the static, delivering a stronger signal-to-noise ratio, which means images that have less interference. It's like trying to hear a whisper in a noisy room. Landsat 9 quiets the static so we don't miss anything important. And that clarity makes a difference, especially over dark surfaces like water, which can harbor harmful algal blooms that can spread quickly, threatening drinking water supplies, local wildlife, and even human safety. By spotting these blooms with greater sensitivity, Landsat 9 gives communities and scientists more reliable and actionable information to respond. Landsat 9 doesn't clock out when the sun goes down. Its onboard thermal sensor, TEERS, measures our planet's surface heat even in the darkness. That means we can monitor urban heat islands, volcanic hotspots, and water temperature at night. Since 2022, the U.S. Geological Survey's Special Request Data Program has implemented the Landsat Extended Acquisition of the Poles, or LEAP for short, taking advantage of Landsat 9's ability to see in the dark to acquire imagery in polar regions year-round, when the sun can set for up to 6 months at the poles. Together with Landsat 8, the satellites can detect features like meltwater, cracks, and even open water within ice under low light conditions. The enhanced coverage helps scientists better monitor ice dynamics and seasonal changes in polar regions, detecting calving events, surface melt, and changes in sea ice extent even during the dark months. Landsat 9 isn't working alone. It's part of a global team of satellites where collaboration across agencies and nations is giving us the clearest, most consistent view of Earth yet. NASA's harmonized Landsat Sentinel-2 project fuses data from Landsats 8 and 9 with that of the European Space Agency's Sentinel-2 A, B, and C satellites to form a seamless, consistent surface reflectance record. In this virtual constellation, Landsat 9 contributes its spectral precision and calibrated data, helping enable global observations every 1 to 2 days at 30-meter resolution. Landsat 9's high-fidelity, radiometric stability, and continuity anchor HLS, ensuring that the fused product maintains the scientific integrity that Landsat users expect. Landsat 9 is more than just today's mission. It's part of the foundation for the future. Through the Sustainable Land Imaging Program, NASA and the U.S. Geological Survey aims to preserve our ability to keep a continuous, reliable record of Earth's land for decades to come. That means not just flying satellites, but building the technology, partnerships, and planning needed to keep that record unbroken. Within SLI, NASA's Sustainable Land Imaging Technology Initiative is testing new instruments that can make future missions smaller, more capable, and more efficient. Landsat 9 is NASA's first SLI mission and plays a key role here, setting the benchmark for data quality and coverage, proving what works today and guiding the technologies of tomorrow. Its stability and precision are hallmarks of previous lessons learned, allowing scientists to trust the record across decades, and its success helps guide the innovations that will come next. For more than half a century, Landsat satellites have given us an unbroken record of our changing planet. In just 4 years, Landsat 9 has brought that vision into even sharper focus, capturing millions of scenes, advancing how we track water, ice, and land, and strengthening the world's longest Earth observation record. It's not just another satellite in orbit. It's a bridge, carrying the Landsat legacy forward with enhanced technology while preparing the foundation for the future of sustainable land imaging. Because with Landsat, every image is more than a picture. It's a calibrated digital record, providing knowledge we can use to understand, protect, and sustain life on Earth.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that Victoria's already critically endangered brush-tailed rock wallaby population is now being further threatened by small population sizes, a lack of genetic diversity, introduced predators, especially foxes, and climate change. Brush-tailed rock wallabies are one of Australia's most vulnerable marsupials and have already almost been wiped out in Victoria. The new findings, reported in the Journal of Proceedings of the Royal Society of Victoria, show that numbers declined dramatically during the late 19th and early 20th centuries following European colonisation, leaving just 3 populations left in the state. The authors say potential solutions include managing predators more effectively, moving wallabies between populations to boost stagnant gene pools, and studying how these animals will be affected by ongoing climate change. A new study warns that teens who use cannabis are more likely than those who don't to develop psychiatric disorders, especially bipolar disorder and psychosis. The findings, reported in the Journal of the American Medical Association, studied some 463,396 American adolescents aged between 13 and 17 who were screened for cannabis use. They found that using cannabis over the past year was linked to an increased risk of psychosis, bipolar, depressive and anxiety disorders by the age of 26. And teens who started using cannabis earlier in life were at the greatest risk, especially for depression and anxiety disorders. A new study has shown that bird watchers are by no means bird brains. The findings, reported in the journal J Neurosci, are based on a comparison of the brains of 29 expert bird watchers and 29 beginners. Scientists found that dedicated bird watchers had denser attention and perception-related areas in their brains, which was linked to more acute bird identification even among older people. The authors reached their conclusions by looking at how water travelled around the participants' brains, finding it spread further and more easily in the brains of experts. The authors believe birding may benefit the brain because it requires a keen eye, paying careful attention, and a strong memory. To see if being a twitcher can provide benefits in other areas of life, the authors also asked participants to remember random faces that were paired with birds, and found even older experts outperform the beginners. The authors conclude that being a bird watcher may benefit the brain and help older people stay cognitively healthy. The world's richest man, Elon Musk, says he doesn't believe that alien spacecraft have visited the Earth. Last month, former US President Barack Hussein Obama said on a podcast that extraterrestrial aliens were real, but he'd not seen any, and they weren't being kept in Area 51.
Are aliens real?
They're real, but I haven't seen them, and they're not being kept in, what is it?
Area 51?
Area 51. There's no underground facility, unless there's this enormous conspiracy, and they hid it from the President of the United States.
What was the first question you wanted answered when you became president?
Where are the aliens?
Where are the aliens?
That prompted this response from current President Donald Trump.
He made a big mistake. He took it out of classified information.
And that forced Obama to quickly issue a carefully worded clarification on Instagram, claiming, and I quote, "I saw no evidence during my presidency that extraterrestrials made contact with us," unquote. The skeptic's Tim Mendham says it's all very amusing.
Yeah, Elon Musk is probably a hero of your readership, isn't he? Or your audience. He's so spacey. Elon Musk has said he does not believe UFOs exist. He actually says there's no evidence to suggest that UFOs exist as a sign of alien intelligence or extraterrestrial travelling. The implication is that he's got so much stuff up there in space, thanks to SpaceX and his satellites that he's always putting up there, that surely they would have come across alien craft at some stage. It needs better evidence, and so far there ain't any, and I think the skeptics would agree with that. They said, we're waiting for the evidence. In this particular case, he should have the evidence because of all the traffic that he's creating in space, but he doesn't.
He's just relying on science, isn't he? The science says that if there are extraterrestrials out there, they're so far away, it'd be really hard for them to get here.
That's right. I mean, he has said that life in somewhere out there in the universe is probably quite likely, but nothing here, and certainly nothing that would imply craft that are being flown around the skies. As he says, it might be terrestrial technology of some sort or another. This is the story about mystery planes and that sort of thing, that are sort of military planes. But he said no evidence put forward that he can see, which is scientifically based, that there's a UFO, UAP, alien craft flying in our atmosphere.
That's the skeptic's Tim Mendham, and this is Space Time, reminding you the truth is out there. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.